no one can quite agree. I'm talking about what's going on that actually makes flight possible, okay? Because that is the cause of a very massive and often quite spicy row.
That was a disappointing video by Hannah Fry, because when you start your video like what we just watched, and the cover for your video literally says no one knows how planes can fly, then you perpetuate the myth, the dangerous myth, that we don't know the physics behind flight and lift. And of course, it will be a surprise to no one that we do know the physics behind flight and lift, and that we do know how to compute the numerical solutions that control airflow around a foil that make lift possible in a plane. She is, of course, not the only one that is propagating this myth about flight, and in particular, this awful article from Scientific American in 2020 that no one can explain why planes stay in the air has done a lot of damage. And Hannah is also not the only one on social media who has propagated this myth. This video was actually taken down after mountains of criticism for spreading this. I think what she was trying to say in her video is that many people get the explanation, the physics behind flight wrong. And she mentions pilots as a group of people that cannot agree on the physics of flight, but why would you ask pilots to settle a question about physics as if they were an authority on the matter? We know that on the internet, people can't agree on very basic mathematical facts, such as the fact that 0.999 repeating is equal to 1. But they do not agree because they don't know what they are talking about. This, by the way, is another article from Scientific American with that headline. Shame on you, Scientific American. This Scientific American article was so terrible because of the clickbait headline, and also because they waited until the last paragraph to explain that we do understand the physics of flight, but it's just that there is not one single physics principle that explains the whole phenomenon. You have to use several physics laws that complement each other to explain the totality of this very complex physics phenomenon. And Hannah, at the end of her video, also alludes to this.
But even NASA has weighed in on this and said, look, calm down everybody, it's both Bernoulli and Newton.
But we do not need NASA to tell us that we need both principles. There are textbooks on aerodynamics that explain all of this. This textbook by Anderson, for example, it's excellent at explaining everything about flight, the physics of flight, and then also how to compute airflow. And in particular, if you jump to section 5.19 in this book, there is a very concise explanation of the physics of flight, of lift, and it shows how you have to put together several physics principles. The second and third laws of Newton, you have to use the mass continuity equation, Bernoulli's equation, Euler's equation, just to take into account all the complexities of this phenomenon. This is another textbook that is great. It also has a non-technical explanation of the physics of flight, and it also goes through all possible explanations that have been used in the past and why they are flawed. And there is this great section in the book about why there have been so many misconceptions, and it is because there is not one single principle that explains everything. It's a very complex phenomenon, and you really need to put together a lot of different principles for it to work in all scenarios. And here the author makes a more important and perhaps more interesting point, that to actually numerically compute the solutions to lift, you actually have to solve the Navier-Stokes equations, which in part explains why we are so interested in Navier-Stokes equations and why one of the Millennium Prize problems with a $1 million reward is to prove the existence of smooth solutions to Navier-Stokes equations.